On behalf of RBCS, welcome everyone. Today on this webinar on the ongoing suckiness of software quality and why it happens. I am Rex Black, president of RBCS, a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, we have delivered insight and confidence to hundreds of clients around the world. We have a team of international consultants who deliver customized training, consulting, and outsourcing services for companies that are looking to improve their test and quality assurance practices. I'm the author of many books on software testing, as well as being the past president of the ISTQB. Attendance at today's webinar does earn PMI PDUs. I would like to thank Vicki Sasser for reviewing the materials for PDU status and for making valuable suggestions. Attendees will receive an email telling them how to claim PDUs, including the PDU code. PDUs are available for live webinar attendance only. Before we start the presentation, a couple notes. If you have any questions, feel free to submit them at any time during the presentation via your webinar interface. Please note I will be answering them at the end. There is no need to ask for presentation copies. The presentation is on the web, rbcs-us.com, in the basic library. While you're there, check out our new mobile-friendly website, which just kicked off on Friday. And so far, so good. We haven't had anybody tell us that they've had problems with it, and we've had people say they like the way it looks. So take a look at it. By attending this webinar, you are automatically registered for the free e-learning drawing. So check your email over the next couple days and watch the spam filter. I hope you enjoy this free webinar from RBCS. We do these free webinars as a service to the software testing community because at RBCS we are a not just for profit company. So you may not know who this guy is, this guy that you're looking at here on your screen, but if you don't know, he's the fellow is named Sisyphus. Sisyphus got the gods, the ancient Greek gods, angry at him and was condemned to spend every day carrying or rolling, depending on the version that you read, a stone up to the top of the hill, and once it got to the top of the hill, the stone would then roll down the hill, rolling over him in the process. As you can see, he's being not exactly assisted, but hindered by various nasty, nightmarish-looking critters there. I think this might be a Hieronymus Bosch painting, but a similar style anyway. So you can maybe relate to Sisyphus now. You feel like, God, I spent my whole career working on improving software quality, and it still sucks. Why? Why is software so bad? So, a good question. Now, it didn't start with the beginning of your career or the beginning of my career. Not sure which one came first. Mine was in the early 80s. Software quality has actually always been bad. And in fact, software quality was bad before there was even software, or at least there was thought of it being bad, as I'll explain later. The difference is that now, unlike in the 50s, software is actually absolutely everywhere. You are almost certainly within arm's reach of software at this very moment, possibly two repositories of it, the PC and the smartphone. And those two items and the software on them are just crawling with bugs. And these bugs are very, very expensive. They cause a tremendous amount of damage to the world economy in terms of lost productivity at the very least. Excuse me, sometimes other damages. And in some cases, people get killed due to software bugs. That's not so great. These bugs are not just a matter of irritation. They are a drain on the economy and a threat to human safety. So given that that's the case, how is it that we're putting up with this situation? Why is this acceptable to society and to governments and to individual purchasers and enterprises? What's the story? Why do we collectively put up with software that sucks? I mean, after all, if you look at our colleagues in the world of manufacturing, they are able to achieve Six Sigma levels of quality. And if you're not aware of what that is, I will be explaining that here today, comparing software quality to manufactured quality. And I mean, geez, we're high tech. We should be better, right? I mean, if you can consistently turn out a can of beans that doesn't give people botulism, then shouldn't we be able to consistently turn out software that doesn't waste people's time or potentially kill them? So what's in our way here? So Six Sigma. Let's talk about Six Sigma levels of quality. What is Six Sigma? A Six Sigma level of quality. Okay, so this is statistical process control stuff, and if you're familiar with the whole Six Sigma black belt kind of thing, that was a very big deal in the early 2000s, popularized by its use by Motorola. Basically, Six Sigma refers to you have a process, and this can be like manufacturing beans, canned beans, for example, and the process has a specification size or something to it. Let's say that when the lid is put on the can, that the machine that's putting the lid on the can has a certain diameter that it's aiming for. Okay, say, I don't know, 10 centimeters, well, not 10 centimeters, 10 centimeters, let's say, or 20 centimeters or 8 inches, what have you, right? So that's the specification. Now, the thing that happens in manufacturing is you always get some variation around the target. At some point, what would happen if the lid of the can is not a right enough size, close enough to that target of 8 inches or 20 centimeters or what have you, that the can won't actually properly seal, and you're going to have a spoiled can at that point. It won't properly seal, it'll leak, and that potentially has safety issues. So the variation is going to tend to follow a normal distribution, which you're seeing here with this figure that I borrowed from apotokyo.org. So you see that. Let me get a highlighter up here so I can kind of. So let's say this is our specification of 8 inches. Okay. Now you're going to get some sort of distribution around that target. And there's the upper specification limit and lower specification limit. These are the acceptable ranges of variation, say 8.05 inches here, and 7.95 inches here. And so if it's less than 5, if it's within 5/100ths of an inch of 8 inches, it's going to be acceptable. And if it's outside of that range, it's going to be unacceptable. It's going to be waste. So basically, outside of these red lines, any can that comes off the line that's outside of these red lines is going to have to be thrown away. Now, the number of items that fall outside will be statistically determined based on the distribution here. And so what we're seeing is one standard deviation, or one sigma. At that point, only 31% of the area of the curve is actually inside of these two red lines. So in other words, 69% of the cans coming off the assembly line would be waste. That's 1 sigma level of quality. That's obviously unacceptable. Now, if you can get it up to 3 sigma level of quality, 93% of the stuff coming off the line is going to be acceptable. You're going to be wasting 7%. But if you get to 6 sigma level of quality, that's what's shown here, there are basically going to be 3 defects per million items coming off of the line. Okay, so that's what you're targeting with a Six Sigma level of quality. You want to have your machines all calibrated such that they are producing something where the item is on average exactly as specified. So in other words, if you average together across a million cans, the average size of the can is 8 inches exactly. It's not slightly above or slightly below, and that you've got 99.9997% of the cans are within that 0.05 of an inch tolerance. Okay. So, software. What about software? How are we doing with software? Well, not good. Okay, we comparatively suck. So Capers-Jones has done a bunch of studies, and what he shows is that typically software industry typically releases 13,000 defects per million lines of C++ code, which should be about the same for Java. Okay, that's following a typical development practice, and that's after 85% of the defects have been detected and removed. So defect detection effectiveness would be 85% or above. In other words, if we find 85 defects during testing and the customer subsequently find 15 defects, we have detected 85% of the defects. So that's 85% defect detection effectiveness. Doesn't necessarily mean that those defects will all be removed, but one would hope that they would, or at least some significant number of them. Now, we have clients that regularly achieve 99% defect detection effectiveness. So they find 99 bugs in testing, 1 bug goes out to the customers undetected. So, I'm not saying that that's the exact number, but of 100 bugs delivered to the test team, they will find 99 of them and miss 1. Now, so let's suppose that we could push everybody up to that 99% defect detection effectiveness, and let's suppose that every bug that we found got fixed. Well, you would still be releasing close to 1,000 defects in a typical million-line C++ program. Oh, okay, well, geez, that's not, that's a long way from 3, right? Because Six Sigma would say that we would have 3 defects per million lines. But actually now that depends on how we measure our Six Sigmas, doesn't it? So we're saying, okay, each line of code is an opportunity to have a defect or to have to introduce a defect and deliver a defect to a customer. That's one way of looking at it. But we could also say, well, what about the fact that unless you have some sort of defective copy system in producing copies of the software, actually every bug that is in one copy of the code will be in all copies of the code. So in fact, your yield is 0%. In other words, 100% of the copies of the application have those 1,000 or 13,000, 1,000 being best case, 13,000 being typical case, defects. So, that's really bad. So this is why I'm saying software quality sucks, because compared to manufacturing, we do very badly. All right, so I made a point at the outset that bugs have been with us since the start. So this is the famous Grace Hopper bug report that actually has a real bug on it, and is historically the source of the name bug to describe a software defect. Though actually Boris Beiser has an interesting essay that he wrote where he it defends the use of the word bug for a software defect and says that it might very well predate that. And this would just be a coincidence. Obviously, they had been talking about bugs in the software because notice that Grace Hopper says first actual case of bug being found. The bug the bug had actually shorted out a relay, as you can see here. Now, in fact, the possibility of bugs in software, whether we're talking about physical bugs or bugs as a concept of something defective in the software, goes back even further than that. So apparently, Ada Lovelace, who for whom the computer programming language Ada was named, and poor Ada, I mean, she has a computer language named after her, which is nice, but it's probably one of the least successful languages of modern times. Anyway, Ada Lovelace was the person who was going to program or hope to program Babbage's proposed and never actually realized analytical engine, which was, if I remember correctly, based on the automatic looms that had been developed, and he'd come to the realization, hey, we could use those to do calculations. But one of the things that she pointed out was, well, yeah, but you could have bugs in those. You could have errors in the program itself, and then you'd get the wrong answer. So bugs have been with us since the start, and if we take the numbers that I was talking about on the previous slide, and then make the very modest assumption that there are about 10 million apps in use, which I say is modest because there's probably a good 7 or 8 million apps on the various mobile device app stores. Certainly more than 10 million, but if we assume 10 million apps in use, that would mean that there are trillions of bugs in the wild out there in the software. And again, as I said, every piece of software out there is almost certain to have bugs. There's I've yet to see anything other than trivial software written by first-year college students that could possibly be called bug-free. And of course, it's also user-free, which makes it easy to be free of any user-reported bug. So this is again dismal. It is simply just a dismal state of affairs, because remember, every one of those things is defective. We have effectively 0% yield compared to 99.9997% yield for modern manufacturing. All right, so excuse me. The core of our problem here is that software engineering is not a true form of engineering yet. It can be, and hopefully ultimately will be, but at this point it's not. And the best way to convince yourself of that, if you don't want to take my word for it, which you shouldn't, you should be listening to me with full skepticism in deployment here, because I'm saying some I don't know, maybe not outrageous things, but certainly I am confronting you and everybody else in this profession, assuming that you're a software engineer, and I'm confronting myself too with an assertion that what we do is of very bad quality. And so I would hope that you are listening to that and saying, okay, I want to ask some questions here about this. So here's my point. Why do I say software engineering is not matured to a true form of engineering? Well, think of how a bridge or an aircraft is designed or built. So you have, ironically enough, computer-aided design and computer-aided manufacturing systems that are used to design bridges and design airplanes, and to subsequently create the materials that those things are built from. And we can predict in advance the load capacity of a bridge. We can predict how it's going to respond to high winds and earthquakes and those sort of things. And it would never be the case of knocking a single a rivet out of a bridge would cause the whole thing to collapse. But such things happen with software all the time. That oh my God, how'd that happen? I only changed one line of code. I mean, and can you actually model the functional behavior of the bridge and predict how it's going to behave under certain circumstances? It's pretty limited in terms of what we can do there. Reliability and performance, yeah, to some extent, but you talk about security and functionality and so forth. No, that's it's not subject to that. There have been efforts to try to do things like proofs of correctness and so forth for software, and it's all fallen flat on its face. So we are way behind our fellow engineers in the civil engineering and aeronautical engineering world. And there's this great quote from Frank Lloyd Wright that I came across serendipitously right as I was creating these slides. He said, you can use an eraser on the drawing board or a sledgehammer on the construction site. In other words, to correct a defect. It's easy enough while you're drawing out the the way that the bridge is going to be built to go, oh, wait, that's wrong, and fix it. But once you start building, yeah, it's going to have a lot of cost. Now, people will say, oh, no, that's not true for software at all. I mean, it's really easy. We just fix the bug and, shoot a new version out there and, everybody updates. Or if it's software as a service, then, it's just people are automatically going to get the fix. Well, yeah, but that you can't unring a bell. If you have put software out there that has wasted a bunch of people's time, that lost productivity is not unlost just because the bug was quickly fixed. Any more than if a span of a bridge collapses and a bunch of cars fall through it, and you say, well, we can fix that span of the bridge real quickly. Yeah, but the people who are in those cars are dead. The cars are destroyed, and you might say, well, that's you're being hysterical here about this because, does software really kill people? Well, yes, it does. There was an incident in Houston where a doctor, ironically enough, in a hospital, got trying to catch an elevator, got caught between the door of the elevator, and while this is not supposed to happen because the software is not supposed to allow this to happen, the software allowed the floor to move while the door wasn't closed. And it acted as a slow-motion guillotine on this guy. It was not a survivable injury. And I could go on. I mean, there are others. So those circumstances, those consequences cannot be undone, no matter how plastic and easily fixed software is and software bugs are. It's you can't undo the damage. Now, okay, so, this is my rant so far, is that we're in the place that we are in with respect to quality. It's bad, and the reason that we're there is because we have not evolved software engineering into a true form of engineering yet. And, it does make sense that would take a while. I mean, it did take quite a while before before aeronautical engineering, which came about probably in the I guess you could say 1905, 1910 time period. It's taken 100 years to get where we are with that, and probably took about 50 years before it was really true engineering. There were some pretty spectacular mistakes made with the early jet aircraft, for example. So, we're going to have a ways to go. We are where we are, but what do we do that makes things worse while we're waiting for for software to evolve to a true form of engineering? What mistakes are we making that make the consequences of this worse? Well, there are some, let's look at them. Probably the way to best summarize this is that if you look at Jones's figures, like I said, 13,000 defects per million lines of C++ code is typical, but by ratcheting up your defect detection effectiveness to 99%, you can get that down to 1,000 defects. So that's an order of magnitude fewer bugs. And assuming that we are smart and we focus our testing on the most important bugs, one would assume that that would actually be more than an order of magnitude in improvement in terms of the user's experience of quality. So why is this? Why are we inflicting 10 times as many bugs on people as we could? Well, I mean, a lot of it is just because if you go and you look at the way people develop software, it's 25 plus years in the past. Best practices are not in deployment, as it were, and software testing is even worse than that. I mean, there are techniques like equivalence partitioning and boundary value analysis that have been described in easily accessible books, Art of Software Testing, for example, for 40 plus years. But I still find testers who don't know them, or they know them, but they don't use them. They don't know how to use them. So, if we apply these techniques, that's how you get to that defect detection effectiveness of 99%, and that's how those defects get removed and fewer defects get put there in the first place. So what's standing in our way here? Well, probably one of the biggest problems, biggest root causes of sloppiness, which is, I think, a fair way of saying fair to follow best practices, is schedule pressure. So you get these unrealistic schedules that get put in place. They're driven by marketing pressures, and there's ideas that we absolutely got to be first to market, et cetera, et cetera. And you might say, well, we're agile, so we don't have schedules. Oh, you certainly do. You have a schedule that every 2 weeks or every 3 weeks or every 4 weeks, you're going to have to produce potentially shippable software. And the way that this problem manifests itself there is not too short of a schedule. It's too much in each iteration. And I've seen this happen plenty of times. And yeah, you're supposed to be able to use burn down charts to try to measure how you're doing and so forth. But, you still see it. I mean, people want what they want. And when that collides with reality, they still want what they want. And this problem has existed since the beginning of software engineering. You've got Fred Brooks in the Mythical Man Month describing IBM projects that he worked on in the 1960s. And he's talking about 20 pounds in a 10-pound bucket, and basically this problem of trying to do too much, too little time, and too little resource. And this is a top-down problem. I mean, this is management coming to the individual contributors and saying, thou shalt do this. And then people like go, oh, well, gee, and oh, come on, be a team player. This is really important. And then when the individual contributors, don't achieve what was never possible to achieve in the first place, then management effectively punishes that failure. Withholding of bonuses, actual, dinging people on performance evaluations, various other forms of punishment or withheld reward. And as testers or in any other quality activity, reviews and so forth that are subject to this as well, what we do is something that is infinitely compressible, right? I mean, I can run one test case and be done testing, quote unquote, in 2 hours, or I can run 1,000 test cases and be, quote unquote, done testing in 5 days or 10 days, depending on how many testers I've got, right? Either way, I'm done testing because I've done all the testing I'm going to do. So this is the thing that tends to happen, and I see this happen. I've seen this happen over the years on lots of waterfall type projects, but it also happens on Agile now where, hey, the sprint's over, so we must be done testing. Really? And that can be exacerbated by the fact that we're not able to calculate defect detection effectiveness, and so I'll come back to that later. So, this combination of schedule pressures and the compressibility of software testing and other quality activities is, going to hurt us. And not only does testing get pressured on the schedule side, it also gets pressured on the monetary side. So you get this lack of funding, and excuse me. I don't hold us, the quality professionals, entirely blameless in this, because I don't know that we always do a good job of making the business case. And there's a very compelling business case to be made using a very well-established quality management technique called cost of quality. But a lot of people don't know how to use cost of quality to make the business case for testing and quality. And if they do know it, they don't necessarily use it. And, you have to understand that our predicament here is different than the predicament that the developers are in. I mean, yes, the developers are going to be pressured and put under schedule pressure, but, everybody understands that without developers, or with fewer developers, you get less code, and without developers, you get no code. But, one tester, 10 testers, I mean, I still get testing, and I still get to say I've done some testing. And this is where we kind of get ourselves in a trap, and why we really need to be able to quantify things like how much risk mitigation are we providing, and how much savings are we providing in terms of cost of quality and so forth. Because what you see is that the average software development professional, software engineering professional these days, and even sales and marketing people, are what I call vaguely religious about testing and quality. Now, what do I mean by vaguely religious? Well, it's kind of like if you look at sociological studies that have been done in the United States over the last 10, 20 years, most people in the United States will say that they have a religion. There are actually very few self-described atheists in the United States. Now, this is just a sociological metaphor here. I'm not making an argument one way or the other. So 95+% of people in the United States will say, oh, yes, I've got a religious faith, and they'll be willing to say, okay, this is what I believe, and this is my religion. But what happens if you drill down on that is really interesting, because if you ask people, well, when was the last time you were actually in a mosque or a synagogue or a church or a temple, it gets, this is my brother-in-law's bat mitzvah, or my sister's wedding, or something like that. So not very frequently. So again, the metaphor that I'm making here is that people in software engineering feel about testing and quality the same way that a lot of people in the United States feel about religion. They say they have it, but they don't set aside a lot of time and money for it. Okay, so it's our job as quality professionals to do a better job of convincing our fellow software professionals that they need to set aside more time and money for testing and quality. Not because it's better for us as the quality professionals. That's a total loser argument. I want you to give me more money because I will be happier, is the worst possible argument that a test manager can make to anybody with budgetary authority. You will never, ever get more money with that argument. You got to basically, the two important things to remember here about making a business case for any kind of change, including increasing the amount of funding for testing. One is that people move away from pain about 10 times faster than they move towards a desired state. This is why people, make New Year's resolutions, and they sign up for the gym and all that stuff. And, the gym is packed in January, and half of those people aren't there by about this time in the year, because the desired activity is to be healthy, right? But you want to find people who are really serious about exercise and working out. Show me somebody who's, under active doctor's care for diabetes or has had a heart attack or something like that. Those are the folks who are going to join the gym and stay in the gym because that's necessary to move away from pain. Now, the second thing here is when you're going to talk about pain and alleviating pain and using that to motivate change, don't talk about your pain. Nobody cares about your pain. Your mother cares about your pain. Your father cares about your pain. Your relatives and so forth care about your pain. But, at business, your pain, that's not an argument. You got to make it about the organization's pain. Be able to point to this is how much money we are losing every year because we ship buggy software. Cost of quality will allow you to do that. Point to problems that happen in terms of things like performance and reliability, and this is why we need a more realistic test environment so that we can do more realistic performance and reliability testing so that we don't have the kind of disaster that we had on product X, right, where you're able to point to something that was released 3 months ago and was a disaster. Okay, so learn to use these techniques to proselytize for better quality. And we also need to do a better job of measuring quality and the impact of not having it. So, I was using defect density because we've got it and it's easy to measure, but it's really kind of a fairly weak surrogate metric for quality. You could have two applications that had the exact same defect density, in other words, the number of defects per million lines of code, that would be of a very, very different level of quality just based on customer satisfaction and fitness for use, depending on what kind of defects they had. And so we don't really have good measures here, and where we are able to do measurement of things like, what level of risk are we taking by using risk-based testing and using traceability of our test results back to the risk to be able to say these are the risks that are mitigated, these aren't. Being able to talk about confidence, about confidence building, and by talking about code coverage, or not code coverage, but requirements coverage. We don't always do this very well. And it is certainly the case that when we have good measures, we don't always use them as effectively as we could. We sometimes, when we're as test professionals, quality professionals, saying, well, results aren't so great, blah, 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 look at all these failures. People say, oh, geez, you guys, you testers are always being negative. Come on, it's going to be fine. I remember giving a presentation once on just some abysmal testing results, and then, I was told, look, like that, none of those bugs are customer facing, whatever that meant, like a bug, it turns back on the customer. People basically were encouraging me just, tone down the findings. I went into a meeting with some company executives, a separate one-on-one meeting, and I was told before that by the project managers, hey, don't paint too bleak a picture here. The project's going to get canceled. And I'm, oh, okay, great. So in other words, if I go in there and tell the truth, then and the project gets canceled, it's my fault that everybody lost their job, right? It's not the fault of people who built the bad software to begin with, right? That the project got canceled. It's my fault for telling the truth to the executives. Now, we have a similar problem with productivity metrics on software, and there's a great book by Capers-Jones called Economics of Software Quality, which I'd encourage you to read if you get a chance. And he makes this argument that one of the problems that we have is, our estimation is very bad because we aren't very good at measuring productivity, and so we measure the wrong things. We have trouble measuring quality, we have trouble talking about quality, we have trouble measuring productivity, and rewarding for good productivity and good product quality. So, surprise, surprise, people make bad staffing choices. insufficient staffing in certain areas. So we really do need to get better at this, and there are best practices out there, but we need to adopt those and adopt them in a uniform way. So people are looking at cost of quality, people are looking at defects, they're categorizing defects using the same scale, so we can start to benchmark our organizations against industries, and it'd be great if we could develop some sort of industry wide pool of defect data that could be studied. I mean, there's a number of things that we could do that we're just simply not at this point. Again, I'm talking about stuff that can be done now. The long-term goal is, of course, becoming a true form of engineering, but we're not there yet. Now, as long as we are not a true form of engineering, what we really are is more like a craft than engineering. And I actually gave a presentation on this a while back, where I talked about this, what attributes of something being a craft rather than being engineering. And I mean, people like to buy craft-built furniture and so forth, or craft-built armoires or cabinets for your kitchen and that sort of thing. It looks all very nice, but you would not drive over a craft-built bridge. Would you? Oh, proudly built by the craftsmen of San Francisco. Here's a bridge. I'm going to drive over, 10 kilometers or 6 miles of water. No, you wouldn't do that. What people who build bridges are licensed professional engineers, at least the people who do the design and so forth. Now, standing around and, pouring asphalt and concrete and riveting I-beams together, those are just, plain old construction workers. But, we're not in that place at all with software. We're not, we have to be a true form of engineering in order to achieve that. So in the meantime, basically, most of the work that's being done with software, ironically enough, is hand done. And I say ironically because, again, remember, the ability to build these enormous bridges and this tremendous airplanes and so forth is all enabled by software. So software allows other engineering professions to do things that the software profession can't do. So if you look at the people who are building bridges and designing airplanes and so forth, these are licensed professional engineers. Okay, what makes somebody a software engineer, a software tester? A lot of times it's just because they said so. And you could say, well, that's absurd, but the thing is that because the widespread failure to follow best practices is so pervasive, so pernicious, is it a surprise that anybody can say they're a software tester? Well, if there's no expectation or very little expectation that people who are doing software testing are going to know core best practices, some of which have been around for 40 plus years, what makes qualified? Well, I mean, at some point we just have to start saying, no, look, let's get these quality and productivity measures in place, and let's, start to measure what happens when you have qualified versus unqualified people. Because if you can't do that, one of the things you get is what we got starting in the 90s and what continues now, which is this race to the bottom with outsourcing of software development. No offense to folks who are listening to this who are working in outsourced, offshore software development entities, and I'm sure that some of those do very good work. But the main thing that has driven companies to move development work and testing work to other locales outside of their offices is not convenience, because it's inconvenient to have work distributed. It's just harder to manage. The thing that's driven it is people look at costs. They're like, well, okay, $10 an hour for a developer in wherever versus $150 an hour for a developer in the United States. Oh, okay, that's a no-brainer. We're going to do that. Well, it's a no-brainer if what you are buying is hours of people's time. But of course, you actually don't care about hours of people's time. What you care about is the quality and the volume of the features produced. So again, back to needing good quality and productivity measures. What can we do about this issue of qualifications? Well, certainly if we can say, look, we want to see people with good, reputable, credible, valuable certifications in software development, in software testing, and that should just be seen as an entry criteria. Now I know people don't like that, and they go, oh well, should I have to take this test, and why should I to take this training? I'm not saying training here. I'm saying passing an exam, and be skeptical here again about these exams. Talk to the people who are providing the certification about how the exams are developed and how the exams are proven to be credible through psychometric analysis and so forth. And that's the kind of thing that we should be insisting on. This is not about just passing an exam that was put together by who knows who. And this is about having passing an exam that's actually credible and that tests your abilities against established learning objectives that are consistent with best practices. Excuse me. So the thing that I would say that is one of the most toxic elements of what's happening here with software quality is that you have software companies that are effectively able to transfer the cost of their bugs onto their users and customers. Now, this kind of varies. So, a lot of times when companies hire third parties to develop software for them or use outsourcing firms, there's what's called a warranty period of 30 days or 60 days or 90 days. And any defect that's found in that period has got to be fixed at the vendor's expense. But, you look at like large enterprise software companies, and I'm not going to name names here because it'll sound like I'm picking on people, but you could figure out who I'm talking about. Companies that sell software to other companies that those companies use to manage their workplace. Most of these enterprise software companies make more money from supporting from technical support, basically selling bug fixes, than they do from selling new software. Why would that be? Why would this is like if a car dealership made more money from its shop and repairs than it did from selling cars. What kind of incentives would that create in the car business, right? Basically, what happens is a lot of times companies that create software are financially incented to release software that meets minimal quality standards. That's it, right? If they can get it out the door to the customer and it looks like it's kind of sort of good enough to use, then you get them hooked effectively, right? Especially if you're talking about enterprise software or any other kind of software that's got high barriers to exit, where it's really expensive to change. I mean, imagine just for example, how bad would Microsoft Windows have to get before all the companies using Microsoft Windows decided, you know what, we've absolutely had it. We are going to Linux. Linux is free. The quality of Linux is better. And we are just going to figure out how to do without Windows and without Microsoft Office, so on and so forth. The barriers to exit there are huge. This is why you read stories of companies that left a Windows world for Apple or Linux, and it's just man bites dog story. That's why they're seen as spectacular. Now you might say, well, where the trend is away from buying software anyway. The trend is for software as a service. And so, then, that's the bugs get fixed right away and so forth. Well, yeah, I would just say that actually increases the issue here rather than decreases it, because it now takes it completely out of your control. Now, I totally accept that this has been a real marketing coup by the people who push software as a service, because it makes accountability for quality even less. And, yes, I've heard this fail fast, Okay, that's easy to say if you're transferring the cost of the failure onto somebody else, right? But there are costs of external failure, and they are borne by someone. It's just, unfortunately, they're not always borne by the companies that incurred the cost of failure. So, what we need really here is some sort of implied warranty of fitness. I mean, if you bought a car and that car was sold to you as a car that was friendly to the environment and got good mileage and so on and so forth, and then it turned out that somebody had actually engineered some hoaxware, some cheats into the software that was allowing it to defeat environmental testing, there would be consequences to that, wouldn't there? Yes, there are. Ask Volkswagen right now. They're looking at billions of dollars in fines. This is going to cost them a tremendous amount of money. But when was the last time that you saw a software vendor held accountable for shipping software with massive amounts of defects in it and the productivity hits? Now, you could say, well, this is different because that's inadvertent. I would say, no, I'm calling BS on that. It's not inadvertent because application of best practices, as I just showed, can reduce the number of defects by an order of magnitude. So this is a choice. There are choices that are being made in this industry that are leading to the current levels of quality or lack of it. So yes, I think an implied warranty of fitness would be entirely appropriate here. And then I think that the software vendors should be held legally responsible for impact to the safety and productivity of the people who buy their software. And if you consider that an outrageous statement, I would just say exchange the word software for any other product you use in your life and see if you feel the same way about it. Now, of course, in order for this to work, we would have to achieve these better quality measures that I was talking about before, because simply doing this based on defect density is not going to be good enough. Okay, so that's my rant, and I'm sticking to it. I understand that I've made people, well, hopefully I've made a lot of you think. I can see from the questions coming in that some of you don't think much of what I've had to say, and that's fine. I did not put this together expecting that this would be received with loving arms by any means. In fact, Vicki Sasser, when she reviewed it for PDU, said, wow, that's really provocative. And I said, yes, that's my intention, was to be provocative. So, to just conclude here, I mean, hopefully you at least agree with me that the software quality problems have been around from the start. Hopefully I've made that case. Hopefully you would also agree with me that we are not yet a true form of engineering. If I haven't made that case well enough, then go and listen to my recorded webinar on towards a true form of software engineering, which will expound on this in great detail. While we are still on that, what's probably a good 50-year path towards really becoming a true form of engineering, let's just stop shooting ourselves in the foot. That's my radical suggestion for the day. Let's stop making avoidable mistakes. I get that we're going to make new mistakes because this industry is, exploding in terms of what we do and the audaciousness of the things we take on. So we are going to make mistakes. Excuse me. But let's not make mistakes that are stupid mistakes, and let's not make mistakes because we're effectively paying each other to make mistakes. Okay, I mean, just a plea to the managers out there listening to this. I mean, please, I hope you understand that when I was talking about management incenting these bad decisions, it's not an attack on you or your integrity, but it is a challenge to you to think about, when you make decisions, when you do people's performance evaluations, when you put rewards and punishments in place, ask yourself really, what kind of incentive am I sending here, especially in terms of quality, and how would I recognize that these are really, going to be toxic incentives. So, why should we do this? Why should we take these things on? Well, because of the importance of what we do. If all we did was make games like, Candy Crush or the Kim Kardashian game or something, no offense to any of you who may be making such things, but if that's all we did was make entertainment software that ran on people's mobile devices, then I guess I'd be a lot less riled up about this. But, I have clients that are in the gaming business, and some of them, and all of my clients anyway, take quality very seriously because people spend a lot of money on those games and they deserve to be entertained by them. And that's the way that they see it. Now, so think, if you're in the business of something beyond just entertaining, but helping people get their work done and possibly saving lives through medical software and so forth, I mean, this stuff really does matter. So, what we are doing is a huge part of the world economy, is impactful on the entire world economy now, basically. So let's just do it better and do the things that we already know how to do. Okay, so with that spleen venting complete, I'll now open it up for your comments, questions, and reactions. I see that there's quite a few reactions here. I know, Amit, you sent a lot of stuff in, and I'm going to try to get to some of them. Some of them I think I addressed earlier. So if I don't get to all of your questions, it'll be partially because I think I might have addressed that. Okay, one person, Scott, mentioned that he had problems with audio, but nobody else did. So it seems like we did not have audio problems here. So Janet says, Rex, I agree with you. Oops. Rex, I agree with you on a lot of your points. Quality always seems to be the last thing on the project lead's minds, and usually the first thing on the minds of the big managers of a good place to cut. Yeah, and this has been something that has been well known about testing and quality for, as long as I've been in the business. And again, sorry, I had to take a drink of water there. As I said, I think that this is that we as quality professionals bear some amount of the responsibility for this. That we need to do a better job of taking on this issue of proselytization. And I know, Victor, you said that I was. Let's see what this is. Comment kind of something about religion. Are you crazy? He said. Well, hopefully none of you were offended by it. It was a metaphor. I was not talking literally there. But yeah, we need to do a better job of proselytizing for the value of testing. All right, Rich says, howdy again. Thank you for all of your webinars. Which software webinar were you thinking of when you mentioned that QA is not real engineering? By the way, the new website is very cool. Well done. Way easier to find stuff. Cheers, Rich. Thank you for the good feedback on our new website. We have been working on it for months and months now, so I'm glad that it does fit the bill. Assuming that you can find the recorded webinars, the one that you want to find is the one that I mentioned, towards true software engineering or something along those lines. It's probably from about 3 years ago or 2 years ago. It's recorded out there. You can go listen to it. So for those of you who are still not convinced by my software engineering is not true engineering argument, then take a look at that. Okay, so Amit here, let's see, it's a question, fairly recent one, so not one that I would have addressed. When comparing softwares to cars, you used an example of VW fraud. I think a more comparable example is the multiple recalls that car manufacturers do. Just had one for my Kia, something in a fuel pipe. I don't see the car companies being sued for such errors, besides the cost of fixing the problem, which is always higher in an on-premise solution. Well, okay, I would agree, and this is more typical. So, let's go back to what I was saying about if we have an organization that is applying industry best practices, and we agree, and I think we do, that is still going to be releasing software with defects in it. Again, my figures derived from Capers-Jones's study would be 1,000 defects per million lines of code. Would be what would be coming out. So yeah, there are going to be defects, but the organization is doing all they can to avoid that. Just like the Kia probably does all they can to avoid putting defects into a vehicle. And then when those kinds of defects come to light, then basically the responsibility of the software manufacturer is to make the customer whole, basically to fix the problem and without charging the customer, and to do so in a way that inconveniences the customer as little as possible. So in other words, don't charge for monthly maintenance, don't charge for annual maintenance. If I buy a piece of software from you and I find a bug in it, you have to give me a fix to that bug, no matter how long ago I bought that software. You can't charge me to be on the phone with one of your tech support people, and you can't inconvenience me by making me wait on hold for 6 hours to talk to such a person. See, that reverses the incentives, because now the incentive is on the software company to be more careful about the software that they're releasing, right? Because they're going to have to pay for it. They're going to bear the price, at least a significant part of the price, if the software fails in the field. Not all of it, because I'm saying they don't have to pay for the lost productivity. But in the case of a company that is willfully not applying best practices, and in doing so for the reasons that I listed in this presentation, and thus releasing software that has 10 times as many defects in it as they could achieve, then I think that is very, very much like the VW situation. In that it is intentionally doing something that is proven to result in significant damage to the productivity and in some cases the safety of the people to whom that software is being delivered. It is negligence, and negligence that results in harm is certainly a civil offense, one for which you can be sued, and in some cases it can constitute a criminal offense if somebody gets hurt or killed. And that's all I'm saying. Hold software companies to the same standard that we hold every other essential thing that we use in our day-to-day life. There was a case, excuse me, there was a case here in Texas where we had a manufacturer who was making some foodstuffs that ended up getting people very sick. It was this ice cream, and it was unintentional though, and so that while they suffered a great deal of harm for that financially, they were not sued. But there was another case where there was an intentional negligence on the part of, in this case, a coal company, and they were negligent about application of safety best practices, and there was a coal mine explosion that killed a bunch of people, and this trial recently came to a close, and people are going to prison for that. So I don't think that what I'm suggesting here is outrageous, and in fact it's typical practice outside of the software world. It's just that within the software world we have lived in this weird bubble where somehow or another we've managed to convince people that we shouldn't be held to that same standard. And I'm saying that's okay in 1950. That's not okay in 2016. Let's see. Rich says this one, Towards a True Engineering Profession, February 18th, 2014. Yep, that's it. Let's see. G says, about 35 years ago, I worked for a manufacturing company and was involved in an effort to figure out how much could be saved by getting things right the first time. Management ignored it until ISO 9000 came about 15 years later, this was customer imposed. Maybe that's what needs to happen for software. Yeah, I think that having the big enterprise customers starting to really demand a higher level of quality and demand qualifications for those working on the software being built would make a huge difference. Imagine, if all of the Fortune 500 companies confronted companies like Microsoft and Oracle and some of these other big enterprise software companies and said, look, enough is enough. We're sick of all of your buggy software and the impact that it has on our productivity. So we are going to impose some requirements on the qualifications of your staff and on the defect density targets that you need to achieve and those sort of things. These are some measures you're going to make. Otherwise, we're taking our business somewhere else. Okay, that's sort of an Atlas Shrugged kind of scenario, I admit, but just run the thought experiment. What would change? A lot of stuff would change, very, very quickly. Alicia says, thanks, Rex. I love your real talk. Your presentations are rarely filled with fluff. We'll be sharing this with our QA organization. Well, thank you. And I would hope that I could achieve the target of never filled with fluff. So, Alicia, if you ever hear one of my presentations and I stray off into the land of fluff, immediately slap my wrist. Let's see. I managed to touch a nerve here. And I knew I would with that slide. Victor says, when it comes to outsourcing, you talk like an idiot. But then later he says, we still love you. Okay, well, I'll stand by what I said in the sense that, I think, as I did say that there are companies out there that are doing good work. So, if you're, Victor, in an outsourcing company, I'm certainly not saying you guys do bad work. But what I'm saying is that what drove a lot of companies in North America and in Europe to pursue outsourcing of development and software was not a humanitarian desire to spread the wealth of software engineering paychecks around the world. I can assure you of that. Okay, it was a steely-eyed contemplation of the only real metrics that managers thought they had, which is hourly rates. What do I pay for an hour of somebody's time? And as a metric to measure software development by, that metric sucks. It is horrible. You don't care how many hours people spend or what those hours cost you. That what you should care about is dollars per unit of functionality and dollars per unit of quality. Unfortunately, we don't have good metrics for unit of functionality and unit of quality. So absent that, managers use the metric they got. And what always happens when people use a bad metric is they make decisions that they would not otherwise make. Many times those decisions are wrong. Okay. Now, as I said, I'm not critiquing anybody who's working in an outsourced situation, and I think, I think it is a nice side benefit that all this high-tech work and all this high technology got spread around the world so rapidly. But as I said, it was surely not the intention of any of the managers who made those outsourcing decisions at the beginning of the outsourcing wave to do humanity a great service by spreading technology to the four corners of the earth. It was all about trying to save their companies money. I've got a comment here from somebody who had earlier made some comments about wanting to remain anonymous, so I'm going to honor that here. So Anonymous says, those who don't agree with the theme of your presentation need to come to work where I work. Okay, so it's not just me. Let's see. I got a lot of comments here. We got thank you for your patience, everyone. I'm trying to dig through these and give everybody a shot at least getting one or two questions out here. Stefano asks, can the problem with software quality be due to the fact that software development is more closely to craftsmanship? He asked that before I made my comment exactly to that effect, that we weren't quite in engineering practice yet. And then he continued on a little later with a question, is the situation with open source software better? At least in the free software world, they should be free from deadlines. In the software business, we usually put software quality as the first driver in development, but then due to high competition, we are forced to deliver. Okay, so this is a really interesting question, Stefano, of open source quality versus commercial software quality. So one of the early proponents of open source wrote this famous paper, and I can't remember the guy's name, but the paper is called The Cathedral and the Bazaar. Eric Raymond, I want to say, but I could be getting that wrong. Anyway, he is also a guy who made a comment later to the effect of, G says, Eric Raymond is correct. Thank you for fact checking me there, G. Eric Raymond is also the guy who made the comment later that given enough eyes, all bugs are shallow. And so he's basically making that argument, Stefano, that with open source software, you don't have the usual business drivers that corrupt, that introduce corrupting incentives, and then you've got a lot of people looking at the software, and the people who are doing it presumably because they really care and really love the thing that they're doing. It is a work of passion, and therefore that they would do a better job of it. So I get that part of I get that part of the argument, but two things. I mean, I've yet to see any convincing data that shows me that software quality for open source software is consistently better than comparable commercial software in the same space. So there is no proof that you make a compelling argument, but without data, there's no proof. And the thing that makes me still cast a jaundiced eye towards the assertion of that is the fact that, again, the qualifications of the people working on the software is no more vetted than it would be in a commercial setting, and in fact might be less so. So I'd love to see data on this. I mean, this is another one where there's that claim that agile development methodologies produce better software than V-model development methodologies, and that claim is made over and over again, but where's the data? So it would in both of those situations, I would love to see actual data on that. Rick says your opening slide of Sisyphus is accurate. Yeah, I I thought some of you could relate to that. Let's see. I had some questions from folks who've left, and I'm going to skip those because it doesn't seem right to address that, and not some of the folks who are hung in there. Stefano says, oh yeah, slide 8. Thanks, Rex. That's the one about management enforcing unrealistic schedules. So he says, I would like to show it to our product management. Hey, feel free to forward on this entire presentation. The PDFs are posted. Send them a link and say, hey, take a look at this, or feel free to say, forward the link to the recording, which will be up there next week. Say, hey, give this a listen. You might want to cover your butt, though, and say, oh, by the way, I don't necessarily agree with everything that he says, even if you do. Just say, I don't necessarily agree with everything Rex says, but, he's got some interesting thoughts. And that might provide you with some insurance. Excuse me. Jessica says, there was a statement about testing techniques known about for 40 plus years that many do not use. Where do I find those? Just a Google search may tell me. Okay, so Jessica, here's what I would say. Get a copy of The Art of Software Testing. The book's more than 40 years old. Give it a read. Ask yourself how many of the techniques that are described in there, all of which are still in use and still are recognized best practices. Give that a read and ask yourself, what of these things do I do and what do I not do? Once you've done that, then take a good shot of courage, preferably the caffeinated kind, not the alcoholic kind, because you're going to need all of your wits and focus about you. Get a copy of Boris Beizer's Software Testing Techniques and read that. And read it again because you won't understand it the first time. At least I know I didn't. And then ask yourself how many of those techniques are in use in your organization. Because those are, for the most part, there are a few things in there that I would say are less relevant now. But for the most part, what are in those two books are still proven best practices. And, both of those books are around 40 years old. Why are we not doing that stuff? And sometimes people say, well, it must have proven impractical. No, I have people come up to me all the time and talk about how they applied equivalence partitioning and boundary value analysis, for example, among other techniques, to reduce the number of tests that they had to run in order to achieve a higher level of risk mitigation. They got better testing done with fewer tests. These things are practical. They are in use. It's just that a lot of us aren't doing it. All right, so here we have some case studies, again from Anonymous. Last fall, I asked my manager if the company would reimburse me for a $15 book on testing mobile apps. Test Mobile Apps by Jonathan Cole. His response, why would there be a book dedicated to testing mobile apps? Yeah, right. Well, yeah. She continues, I do what I can with what I have. I have paid for my CTFL class and spent vacation days to do it. I've made peace with this. I share this to make a point. Most class attendees were sent there by their employer. By the way, I paid the $15 for the book on mobile testing and found it immensely helpful. I'm in talks with Randy Rice about attending his mobile class in Irving soon. I would hope that those of you who are looking for a class on mobile testing would consider the RBCS class on that. Well, shameless plug. I asked my employer to pay for the mobile class as I did the CTFL class. The answer is still no. However, they won't require me to use vacation days this time. Baby steps, I guess. Yeah, here's somebody, and this person, by the way, again, is going to stay anonymous, but this is a long-time listener of these webinars. So this person invests time every month, about an hour and a half of time to come and listen to these presentations. And sometimes they're sort of more of a rant, like this one was, sort of an exhortation to do better. But more typically, they're about a technique that you can actually use and apply immediately. So this is a person with a demonstrated commitment to increase their qualifications and skills in the face of management obliviousness to the importance of that. So we certainly need a whole lot more people like this person who are committed to increasing their skills, but we need fewer people in decision-making positions who are not supporting that fully, I guess I'd say. So here's a question from Amit. You stated that we can and should define a unified approach for metrics, etc. Can such a unified approach fit both mobile apps and avionics? What value can come out of comparing those two? Well, I think, yeah, I think we can we can come up with metrics for quality and productivity that are meaningful across multiple industries. And I've worked with clients across multiple industries, and so I know that there are common solutions that apply. Now, when you talk about comparing those two, well, obviously, again, not to pick on, Candy Crush or, any other particular game, but somebody who's building a game like Candy Crush that runs on a mobile device and has, very, very limited social impact, that's quite different than somebody building software that runs on the cockpit of an airplane, and then if it fails, would cause the plane to fall out of the sky, killing, 300 people. So you have to be careful about comparisons. But I think you can make it more clear that you have to be careful about comparisons when you have these metrics available and you show the averages by industry. And lest you think, oh, well, it would create a temptation to do invalid comparisons. I would suggest that temptation exists already. I went in and did some discussions with some IT folks at the IRS once, these discussions didn't result in me getting any consulting work for them, I think in part because I told them something that they didn't want to hear but was very true. What they asked me was, well, we want you to help us improve our testing practices so we can test more like Google tests. We want to be fast and nimble like Google. And I said, well, I'm sorry, but you don't need to be like Google, because let's think about this for a minute. If Google gets their search software wrong and somebody gets sent to the wrong pizzeria, that's one thing. If you guys get your software wrong and 10,000 people get audited that shouldn't have gotten audited, or 100,000 people's data for the last 10 years gets irretrievably corrupted, that's a whole different thing. So that management reaching for bad analogies and misusing benchmarking, I mean, that problem already exists. The metrics, I think, uniform metrics would actually help us combat that rather than make that problem worse. Let's see. So Victor says, at Cisco, we have a huge issue with hiring people who are qualified to do what we need them to. We are forced to outsource because our policy, USA policy, fails to support high-tech industries. I think you and I talked about it in Washington in 2015. Ah, okay, now I have a face to put with the name. Okay, I would agree that well, this is interesting. So there are government policies in place that have not been helpful, let's say. But interestingly, a lot of those government policies are in place because of pressure by high-tech companies. Because I mean, if you look at the way laws are written, a lot of the time these laws are actually written by lobbyists who then give them to legislators who tweak them one way or the other and put them forward as their own. I know that sounds tremendously cynical to say that, and you might think, oh, that's surely nothing but a conspiracy theory. But I have actually talked to people who work in the Texas legislature who have assured me that is indeed exactly the way it works. So, we kind of, it's you can point at the government and say outsourcing is an outgrowth of policies the government put in place, but then those policies are an outgrowth of industry pressures on government. And, I know I probably sound like Bernie Sanders right now, and that's completely unintentional, but I can say huge. But I mean, it's just, there need to be some countervailing forces with respect to high tech. I think at this point, the various heads of the companies, of these big IT companies, are the ones who get listened to, and it's not balanced out by anyone on the other side, right? We don't have a Ralph Nader of IT, as it were, you know. And so I'm all for, you know, people being able to bring their grievances to the government for redress, and so I don't have a problem with lobbying per se. I think that's protected by our Constitution, but it certainly there's a vacuum here when all the lobbyists are on one side of the issue. In this case, the issue being protecting the interests of high tech and IT companies. So I've probably now at this point managed to offend people on both the left and the right. So you know, I better make that my last political comment of the day. Let's see. I got a thing from Dennis here. It says, Rex, part of the problem is that management also does not enforce using true engineering methods to design software. The proselytizing needs to be done at levels other than just the developer. Absolutely, Dennis. And if I probably should have been even more clear about that. Proselytizing the programmer about upping their quality game is not going to help, because they are under the same pressures you are. And it's not like the developers don't care. You know, I mean, most developers I know are not you know, blasé, like, I don't care about quality. You know, I want to write crappy software and inflict it on my customers. I don't know any developers who ever say that. This is stuff that's coming down from management. People are responding to management pressures and to management processes and so forth. So all of this proselytization that I was talking about really has to be directed uphill. It has to be directed at management. And I know this can be uncomfortable, what I'm suggesting here, because there's some peril to it. You're going and you're as an individual contributor or a line manager going and trying to affect change at a management level by lobbying managers, and yet can that blow up in your face? You bet it can. So, you know, be careful about it. But, you know, I mean, I think without that, we you know, remain in the stuck state that we are. Stefan says, Rex, perhaps your organization could author a preliminary ISO 9000 type set of standards for software development and market the idea of industry-wide adoption to Fortune 500 companies. Likewise for software testing. Well, no, I don't, not quite that ambitious. In part because I think that standards documents of whatever source have not do not have a good track record of affecting change with respect to software testing and software development in general. You know, there was this big dust up over this ISO 29119 standard, and you know, there were people on one side of it saying, oh, this is going to lead to higher quality and better testing, and people on the other side of it saying, oh, you guys are a bunch of evil totalitarian control Nazis. You know, obviously I'm lampooning the claims made by both sides, just because I was the one in the middle of the debate. There was a webinar on this, and I was the one in the middle of it saying, what is the big deal here? That if ISO 29119 has as much impact on software testing as IEEE 829, we're having an argument over nothing, because it just doesn't make a difference. I would rather see the work done on metrics at this point, and how to have better metrics for quality and productivity, and then leave the whole process piece to later. I mean, honestly, if anything, as I said in a webinar a few months ago, if anything, I think there's been altogether too much discussion of process too much fighting about process from CMM and CMMI on the one hand to Agile on the other hand, and not enough focus on qualifications. And as long as we are not a true form of engineering, I think qualifications is going to be more important than process. Let's see. Amit says, to stress the question of various industries, would you say that testing a medical software requires similar skills and attitude as testing quality Candy Crush? Well, I think there are some basic skills and a basic attitude that is true for both. Yes. Now, are there things unique to testing medical software? Absolutely. I mean, one of them being that FDA regulation that you have to comply with. And obviously the fact that it's safety critical means that there are there's a totally different risk profile. But, do I want somebody who comes in with a skeptical attitude and looks for problems and understands basic testing techniques in both situations? Yep, absolutely. Travis says, I'm not sure if you've covered this during Q&A, but my experience has been that developers do not test their own code and continuously pass through bugs to QA staff. Are developers taught how to properly test their code during college studies? Well, if software engineering is still taught basically the same way that it was taught to me in the 1980s at UCLA, then I would say no, because the only time we talked about testing at all was in my software engineering class, which was one of the last classes that we took so it was a senior year class. I was talking about software engineering as a professional industrial practice, and it's a 10-week class. Of that, we spent 1 week on testing. So that's 3 hours. There are 3 sessions, 1 hour each. The last session had to do with system testing, and then the other 2 sessions before that had to do with unit and integration testing. So there you go. Out of it was supposed to be 4 years. It took me 7 years to get through it because I paid my way through college and I was working as a programmer at that time. But on a 4-year education, I mean, I get 3 hours of discussion about testing. Now, I think it's changed a little, but not a whole heck of a lot. Now, there are colleges out there that do teach testing, and that's all to their credit, but I'm not aware of any that make it mandatory. Let's see. So Stefano says, thanks, Rex. Spicy webinar today. I enjoyed it from start to end. I for sure will be one of the most discussed RBCS webinars. Sometimes it's good to say facts straight. Well, I always enjoy getting things off my chest, and so hopefully it's been helpful for you guys too. Testing CRUD, C-R-U-D, is the same in all products, Carol says. Frequently, CRUD is buggy crap. So that's the create, read, update, delete thing. And yes, I totally agree. But that's the idea, that there are some basic concepts for testing that can apply pretty much anywhere. Let's see. Rick said, most of the bugs I encounter, many of the bugs I encounter when testing are unknown requirements or missing requirements or domain knowledge requirements. So there's often a 3-way battle between project managers, developers, and software testers, where the project managers will tell the developers what they want, and then the developers will write the code filling in software functionality details. As the tester, I'm usually not privy to these details until the software is given to me for validation testing. We try to capture some of these details in various tracking tools, but often functionality is discussed and not captured. Unfortunately, we as an industry seem to have regressed with agile development, and the common perception is that written requirements are secondary and only written in high-level terms. This often results in escape bugs to production simply because we cannot test what we don't know. Yes, and this is an unfortunately common story. Let's see, I got an anonymous person here who, in response to our other anonymous poster, said, I second those remarks and also do not want to be named. Cinsa says, great presentation, thanks. So many QA teams identify themselves with Sisyphus. Yes. Let's see. G says, quality begins with requirements. Many times the requirements don't reflect what's actually needed. Goes to the whole fit for purpose thing. Yeah, I mean, if you don't know what's needed, then, how do you build it, right? Let's see. So Amit here to get some of your stuff, and I know you've got backed up, but I'm trying, as I said, to try to spread it around. Amit says the process you described for fixing cars does not apply to washing machines. Is manufacturing washing machines not engineering? Washing machines, I'm referring to the fix always don't charge for maintenance insurance. Okay, so I think it's fair to say that there's a difference between a failure of a mechanical object due to normal wear and tear and failure of a mechanical object due to a manufacturing or engineering or design defect. So if my washing machine breaks because I have had it for years and a belt in it has worn out, then I do not have a reasonable expectation of the washing machine company. In our case, we've got Bosch, I think, is our washing machine that we have. I have no reasonable expectation of Bosch coming out and replacing the belt that I basically wore out through my use of it, right? But if my washing machine, due to a design defect during the spin cycle, the tub broke and shrapnel flew out and injured me or my wife or killed one of my dogs or something, yeah, you bet I'd have a claim to go after them, because that's a defect that they introduced. That's not normal wear and tear. So the argument I'm making here is there's no such thing as normal wear and tear on software. It doesn't get worn out by frequent use. So, that I don't think that the same argument applies here. Amit says, by the way, an idea that might have been already thought of and maybe even implemented. It seems that many of the people here have interesting ideas. I would think I would benefit from a sort of forum discussion board to discuss the webinar further with the attendees. Well, I am happy if somebody, when we post on the RBCS Facebook page, which anybody who wants to can come and leave comments on and read those comments, I believe. I'm happy when we post about this webinar on our Facebook page. If people want to discuss and comment further, I'd be very happy to see that. That's great. Feel free to use that as a forum. Let's see. Ray says, software gets worn out by users trying to do things with it that the designers and developers never thought of. Well, I don't know. I think you're stretching the metaphor there, though. It's not worn out any more than if I use a hammer to do something other than driving nails. I use a hammer to, I don't know, break rocks or something like that. And I don't think it's real good at breaking rocks. And then the designer says, well, we didn't design it to break rocks. We designed it to drive nails. I think that's somewhat different. Now, if your point is that software eventually can become obsolete because the software environment is evolving, I guess I would agree with that to some extent. But, I don't, when I use Microsoft Project, for example, I don't need to do anything differently with it than I did back in the 90s when I first started using it. So I don't understand why I have to buy a new copy of Microsoft Project. I mean, I understand from a software engineering point of view that it's been made incompatible with the latest version of Windows. I have a copy of Project, the 1998 version of Microsoft Project. I can't install it and use it, even though I could do everything that I would want to do with it with that version of Project. There are no new features. Ray says Project 4.0. I don't know what version it was, but it was a 1998 version, and it would still do everything that I would want it to do. So I understand why it's in Microsoft's interest to use planned obsolescence to force me to pay $500 for a new copy of Microsoft Project, but it's certainly not in my best interest, and it's not as if that software was worn out, you know? So, you know, again, I just think that there's some inequities, I guess you could say, in the way that software gets treated preferentially by comparison with everything else that we buy. Claudia says, what are your thoughts on having a QA review process? Developers generally have a process where another dev or manager reviews their code. This has never been mentioned as a best practice for QA. Do you know if there is a reason for that? Yeah, I have been saying that having reviews of testing work products is a best practice for years. And the rule of thumb in my test teams for, almost pretty much as long as I was actively managing test projects, which was, you know, over 20 years, was 2 pairs of eyes. You know, that you nothing is considered done until at least one other person has looked at it. Let's see. So Amit says, for the aspiration of having a credible certification, I see around me many testers who pass the ISTQB foundation level exam and are completely unqualified as testers. What would you say can make a good certification? Also, in your eyes, why wasn't it done? Well, I mean, okay, so let's think about this for a minute. The CTFL, Certified Tester Foundation level, emphasis on the operative term here, is meant to be exactly that, is meant to be a foundation that somebody would take when entering the workforce in order to be conversant with the basic concepts of testing. Now, when we do our courses, we do them as 4-day hands-on courses so that we raise the bar a bit above that, and we actually teach people how to apply test design techniques like state diagrams and decision tables and boundary value analysis and equivalence partitioning, specifically to avoid this kind of perception. But the thing with the ISTQB program that people misunderstand is the foundation is purely an entry level. It is a first step. So just like nobody could go to college, take 1 semester of computer science, come out, and you just quit and go, I don't need any more of that. I'm done. I know as much about testing as somebody who's got a 4-year degree. I mean, that's absurd, right? So if somebody says, well, I've got the foundation level, and no, I'm not going to bother to move on to the advanced levels because, I don't need that. Well, I mean, the advanced level is where all the action is. That's where you're going to be spending most of your time learning these best practices and how to apply them in a variety of settings. You can't do that at an entry level, because that's like saying that when you teach someone English in grade school, the way you're going to teach them English is by having them read Hemingway. So Amit's had a response to that. He says, for the foundation level, when I got my bachelor's in science, I was totally inexperienced but qualified to work at an entry level. ISTQB certification does not provide the same basic ability, but is needed to be a useful entry-level professional, or even being more efficient than someone off the street. Then I guess I would say, Amit, that you have to look at the way in which the people around you obtained their foundation level certificate. If they went to a 2-day or 3-day brain cram course that all it did was teach them how to pass the exam, then they got out of that exactly what they paid for. And the hiring manager who decided to hire that person, by not closely inspecting their skills and qualifications beyond just looking at the certificate, got out of that hiring process exactly what he or she deserved. Okay, because that's just to look at and say somebody passed a foundation exam, therefore they're necessarily qualified to come in and work as a tester. Nobody at the ISTQB makes that representation, at least not that I've heard. You know, if you look at the syllabus and you look at the way the exam is set up, you can have a pretty good understanding of what you can assume about somebody who's passed that exam. If you just go, oh, the certification, bam, you know, and just hire people willy-nilly without looking at anything else, and, you know, again, I'll say that organizations that have such hiring practices get exactly what they deserve. Now, Amit says, then why did they get certified? Isn't certification meant to filter those that are capable to some minimal extent? Isn't that what certification means? Not a foundation certificate. No. A foundation certificate is not going to tell you that any more than having somebody who knows grade school level English is necessarily going to be able to read books by people like Hemingway or other great authors and really understand the depth of meaning in there. It's entry level kind of stuff. Now, I know that you're saying guys that took a 6-month course, again, I'd have to say, well, look at the course and look at what people are actually getting out of that, you know, but apparently not much. Let's see. Lena Bowen here made a comment. Somehow or another it got lost. It was something about a lot of smoke and mirrors about testing. If you can resend that to me, smoke and mirrors about quality. But yeah, I mean, if you can resend that to me, that would be great. But yes, the general point I certainly agree with. Travis says the ISTQB CTFL is an entry-level certification. I took the CTFL exam after 4 to 5 years of software testing experience. The course and exam reiterated what I already knew. The best measurement, in my opinion, is on-the-job, real-world experience. Quality comes with continuous education. Right. Yeah, I mean, this is exactly the way to think about certifications, is as a component of the larger process of improving qualifications, not a replacement. Steve says time check. Yes, I know. I've been running this long. I know some of you might need to drop off. We just had so many questions and reactions to this that I wanted to try to get to as many of them as I could. And I think we're not going to be able to get to all of them. I'm sorry, Amit. I know I didn't get to a lot of yours, but you know, again, if when I will post a link to this webinar and further information about it on our Facebook page, and then people can comment there. Lena says this is the sometimes software quality suffers by smoke and mirrors that is created by unqualified people. Yeah, exactly. I mean, I think that's very, very true. You get somebody who's not qualified to test, that comes in, does their testing, and then goes, oh, I'm done testing, and you know, I have high confidence. Well, you know, take that with a grain of salt. Amit says, thanks, it was interesting. Yes, I found it very interesting, and it was good interacting with all of you. I'm happy to have gone a little long, and I appreciate the 100 or so of you that stuck around this extra time after some of the first 100 or so left to participate in this dialogue. And if you want to continue it on the RBCS Facebook page, that would be fine. I'm glad I was able to provoke some thoughts here, and if you don't agree with me on everything, I'm not surprised. So closing the session down, a brief note about resources, free webinars once a month. Sign up at rbcs-us.com. If you want a special webinar presentation for your company only on any test-related topic, send an email to info@rbcs-us.com or via our website. You can follow us on Twitter and Facebook. Again, I'll post a link to the recorded version of this on Facebook soon, and we can continue the discussion there. And also, I'm going to post a comment about it here where you can continue the discussion right away. Sign up for our free regular newsletter, which will give you reminders about our e-learning, our webinars, as well as various consulting and training services that we have. And do check out our new website. We think it's going to be a lot easier for people to find things and easier to use. We offer all these free resources as a service to the software testing community because, as you all well know, at RBCS we are a not-just-for-profit company. This concludes the webinar. Thanks to everyone for joining us today. Hope to see you on future webinars, which may or may not be equally exciting.